Welcome. This is our first unit of chemistry, and this is the first section. And what I want to start with today is helping you understand how matter is made up of particles. And to do that, I'm going to use something called a Bohr model. The Bohr model was named after Niels Bohr, who was a really famous scientist way back in the early 1900s. And he helped develop what's called quantum theory. And quantum theory says that particles like electrons can only live in certain places. They can't just be anywhere they want to be, but they have to be in certain places. So he developed this kind of model of the atom where we make concentric circles. And I'm pretty sure you learned about this back in junior high, so hopefully this will be a review to you. But let's start with picture. So that little dot in the center represents the nucleus of the atom. And if you remember, the nucleus of the atom contains protons that have positive charges and neutrons that don't have any charge at all. And today we're not that interested in protons and neutrons. We want to look at where the electrons are. So the Bohr model says that we have this one place that we represent with a circle, it's not concentric yet, a circle around the nucleus, where the first two electrons can live. So if this is a hydrogen atom, then that means there only is one electron, and that one electron is going to live in this energy level. We call this an energy level, and we label it n equals 1. We always use n to designate each what we call a principal energy level. And since this is the first one and the lowest amount of energy, we'll call it n equals 1. If this is a helium atom, that means that there are two electrons. Also two protons in the nucleus, by the way. And we would put another electron right there. So now that just became helium. Now, according to everything that we know about atoms, we can only have two electrons living in this particular principal energy level. It only has room for two. So if we have a bigger atom than that, we have to have another principal energy level. Another principal energy level. And this one, no surprises here, is n equals 2. So now we have two principal energy levels, but this second level is bigger than the first one, and it has more room for electrons. Remember that electrons are all negatively charged, and hopefully you also remember that negatively charged particles repel each other. A positive and a negative would attract, but two negatives will repel. So if you get them too close together, it's too high energy, and the atom won't tolerate that. So we can only have two close together, but we get a little further away from the nucleus and we can have room for more. And in this case, there's going to be a total of 8 electrons that can live here. So remember, we said that if there's only one electron, that would be hydrogen. If we had 2 electrons, that's helium. Now, if you look at your periodic table, you'll see that number 3 is lithium. So if I put one electron out here, now I have a lithium atom. And if I put a second electron around here, now I have a beryllium atom. So far I have 4 total electrons. That, by the way, means there are 4 protons in the nucleus. Now, once we get bigger than beryllium, let's see, we're up to number 4. So number 5 then would be, number 5 is boron. Terrible chemistry teacher. And then number 6 is carbon. And then number 7 is nitrogen. And number 8 is oxygen. And number 9 is fluorine. And number 10 is neon. So by the time I get here, I have a total of 8 electrons here, 2 electrons here, so I've got 10 altogether. And that's going to be neon, because neon has 10 electrons, also 10 protons in the nucleus. So let's talk about atomic number for a second. The atomic number, by definition, is the number of protons in the nucleus. I think you already learned this at some point in your careers. Now, if it's an atom, in other words, if it's an uncharged particle, and that's the only thing we care about at this point, then the number of protons and the number of electrons have to be the same. So here's what I'm telling you. If I give you the atomic number, you automatically know how many electrons you have to place in these concentric circles. So the number of protons equals the number of electrons. So as I've been going through this, let's go back and review for a second. I said that if there's only one electron, that means there's only one proton, and we have a hydrogen atom. If I added the second electron, then we have two protons, two electrons, I have a helium atom. When I added the third one, then I was up to lithium and so forth. And if you have a periodic table, you can easily scan right across and see what we're looking at. Just in case you have forgotten, I'll show you a picture of my ripped up periodic table. And the number that's right above the element on this periodic table is the atomic number, and that tells you the number of protons. If you have a different periodic table that you're looking at, usually there's a legend or something that you can find that will tell you which one of the numbers in the box is the atomic number. But it's always a whole number. Usually there's another number called atomic mass. We'll talk about that some other time. And that's usually got some decimal places. So you're looking for a number with a whole number. So let's keep going on this. If I draw the third concentric circle, which is n equals 3, we could have room for 2 electrons here. We could have room for 8 electrons here. But in the third principal energy level, we can have room for 18 electrons. So I'm just going to draw that here, 18 electrons max. And while I'm at it, let's do this. So this will be 8 electrons max. And the first one will be 2 electrons max. And that's enough for us right now. We don't really need to go any past that. But let's just try an example so that I give you an idea of how to do this. So if I were to give you the example of calcium, and you look on your periodic table and you see that calcium is number 20, that means that you have to put 20 electrons into your Bohr model. So let's start down here. And that's our nucleus. And then we'll draw the first concentric circle, and we'll put our 2 electrons in there. And you don't always have to label them if you don't want to, unless you're asked to do that. And then we add 8 here. Okay, so now I'm up to 10, but I need another 10. So I have to add the third principal energy level. But I'm not going to fill it, because if I filled it, I would put 18 electrons, but I only want to put 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this, then, is the Bohr model for calcium. So I hope that is helpful.